I have given this presentation before. It's been a while, so I do apologize if my cadence is a little off, but I think we'll be able to cover everything today. I'm hoping to have enough time to do a Q&A at the end of the presentation, which we can do by chat, and I'll read the questions and I will respond. So today, obviously, everybody knows what a building is, but today we're going to talk about more about what parts make up those buildings, those components that are most important in a building, what holds them up, how they age, how the performance of a building can be impacted by that aging. I'm going to go through some types of deficiencies to look for, to do a visual, non-engineering level inspection so that you can spot things in your buildings or your communities or your homes that may be of concern. We're going to talk about maintenance and replacement of those components when it comes time to do so. And we're going to talk a little bit, touch a little bit in the end on reserve funding and the importance of that and the best approach to that. So buildings obviously are important to us. They are our homes, they are our businesses. The ability to maintain those buildings in a timely fashion will, of course, affect the bottom line. How much does it cost to live in your home? How much does it cost to maintain the structure that you do business in, or the components in your community that are structural, like your clubhouses? Obviously, lack of maintenance can translate into a higher cost of maintaining those buildings and the cost of owning those buildings. So again, obviously a building is an enclosed structure. Uh, so humans have been building buildings of all types for a very long time now. In the modern age, we have modern materials that perform differently. We have ways of conditioning the air in our homes in the past 50 to 100 years or so that are much different than the way we've done things in the past. And there's certain requirements that those systems have to run efficiently. And the components of the building all work together. Starting from the bottom, you have a foundation. The foundation in this particular picture, this is a section. If you were to take the front facade, say, off of the building and take a look at what's inside the building in terms of its actual structure, you'll see that there are footings that are sunk into the soil. There's all different kinds of footings. Some buildings are on piers that go many, many feet into the ground. Some buildings have basements underneath in which the foundation walls are much larger, and there is a below grade either occupied area or area that can be entered. In this particular building, there is what would be known as a crawl space. You've got frost footings, meaning that the footings extend below grade. Depending on where you are in the country, here in New Jersey and Pennsylvania, you want those frost footings to go at least 3 feet below the ground so that they are bearing on soil that is not susceptible to freeze thaw. Those footings extend, as you can see, above the ground, and then the framed structure is constructed on top of that. In our example here, we have a wood frame structure, and the exterior walls form the basis for the structural components for that building. Sometimes, based on the building configuration, there may be load-bearing walls inside that structure that you can't get rid of them. They're part of what holds up the structure. The roof is also structural in that it's framed out in such a way to hold that shape. Some buildings have flat roofs, and there are structures under those roofs, under flat roofs as well, that are load bearing, and they're intended to hold up the structure. So the building envelope are the materials. There's finished materials, obviously, that go on the outside of the building in terms of sheathing and roofing and their underlayments, and then further finish materials that typically go on the facade over the wall assembly sheathing that make our buildings attractive from the outside, whether it's a vinyl siding or a masonry or a stucco or any of the exterior types of finishes that we often see. So let's talk about the different materials used in modern building and how they age. So when we're first constructing a building, we're especially now in this day and age, we are selecting materials that are going to give us the strength that we need to give us that support structure within the building or within the building envelope. The non-bearing materials, we want to select them based on their performance and on their cost. I mean, clearly there are materials such as real stone, um, materials that are like that. They're very, very strong, but they're not very cost effective in terms of affordability for constructing a building. So we use materials that are going to perform and give us, hopefully, if we protect them correctly, continued performance for decades. In wood framing, steel framing, there are certain types of sheathing systems nowadays that are um, have materials that are integrated so that there's an ease of construction and a cost savings there, but they also, when constructed properly, are performing to keep moisture and other types of aging um, actions on the building materials out. So they're strong, they're performative, and they are cost effective. So let's talk about the different types of building materials and how they can be affected. So, as I mentioned before, many buildings are wood frame construction. Sometimes they are on a footing foundation, like we saw in the previous slide. Sometimes they are some buildings that are mid-rise, just a few stories, can be wood frame on top of a concrete a podium deck. You see that often with buildings that are mixed use with commercial or have a parking garage underneath. But the wood frame construction um, can be susceptible to certain types of aging. One of them is rot. When water is allowed to get to the wood framing materials, wood is one of those materials. It's a natural material. It is biodegradable. It can last for many, many years when it's protected under the right conditions. But once moisture gets to it and begins to um, soften the wood and the fungus, any kind of just fungus that's naturally in the air around us, it gets to that wood, it will actually start to eat and degrade that wood for our purposes. So we will often see when we do invasive testing, when we can tell that maybe there's water getting in there. We've done moisture testing, we can tell that water is getting in behind the facade. We will often recommend that invasive testing be performed so we could see what's going on behind those facade materials. So we'll take the facade off, we'll take the sheathing off, we'll look at the framing, and sometimes if there is water that has gotten to those materials, we will see this type of rot. So sometimes it can be repaired in place with certain types of repair materials. Rot Doctor comes to mind. It's a material that can be used to kind of create a faux wood and kind of reform the component in place. That cannot always be done. So like this particular piece right here, we will often take a screwdriver and you can put the screwdriver several inches into that wood. That wood it would be very far gone and you'd need to replace that. As I mentioned before, concrete is a very common structural component material. So in this particular picture here, you see steel reinforced concrete that is creating a building that is several stories tall. The vertical components that you see, there's reinforcement in there. Um, that goes that supports the floors, the different floors, and the floors themselves are also supported either on like a corrugated sheet steel, or there's actually steel reinforcement in a concrete plank. So whenever you have a building made out of concrete, you can guarantee that in there is steel somewhere. And we're going to look at steel in a little bit and how it affects concrete. So here's one here. So that steel reinforcement in the concrete can, when again, just like wood, once the water starts to get to it, you've seen, when metal comes in contact with water, how it begins to rust. And when steel rusts, it actually expands. So whenever you see something like this beam in particular, this looks like it's within a parking garage somewhere. Concrete is very good in compression. Like if you were to take your hands and press them together, that's compression, right? So concrete is very, very strong in compression, and it picks up the forces in the building that compress those components. And then steel is very, very good, has very strong, it's very strong in tension. So if you were to take um, your hands and kind of link them together and pull them apart, that is tension. So steel is very good with those forces, with those expanding forces. So when you combine a steel inside of a concrete component, you're creating a component that's very good in compression, but also can pick up those tensile forces that are applied to those components. So it's very useful in that regard, but you have to protect it because, again, once you get cracks, concrete cracks very easily. It has almost zero strength and tension. So whenever there's areas like along the bottom of the beam where there are more tensile forces than the top of the beam, you'll often see concrete start to form hairline cracks or little cracks at the bottom, and that can happen over time. And that needs to be maintained, because once any moisture starts to migrate into those cracks and actually come in contact with that steel, then the steel starts to rust. As steel rusts, it actually expands and it starts to blow the concrete, if you will, push the concrete off of the outside of that component. And that's why you can see bare steel, sometimes bare rusted steel inside a component like that is deteriorating. So steel itself, we often have buildings that are constructed of various steel shapes, and form the load-bearing structure of a building. And again, steel that is exposed to the elements, specifically moisture, will begin to rust. Oftentimes, when a building is being constructed, when you see the steel being delivered to the site, you'll notice that they're not, those steel pieces often aren't shiny. They have what is called a protective rust on them, or oftentimes you most often can see it in actually street catch basins, the steel grate on the top. When they're brand new, they look rusty. They're absolutely fine, but they have a protective coating, rust coating on them. When steel is used in the building and it's going to be exposed, it's not going to be inside of a building structure. And again, in this case, we have what looks to be a parking garage. We could see the line striping there. So these steel members are exposed within the parking garage. So they'll be coated sometimes with a protective material to protect them from the elements, especially in areas where you're near the ocean, where there's also the action of that salted moisture. That is particularly corrosive to steel. So whenever there's exposed steel, in a finished building, it will be coated in some way. Also, when inside a building, you will often see the steel coated with a fire retardant material um, that covers the whole surface of the exposed steel at the inside of the building. Now, in this particular picture, you see that the steel is starting to rust. You could see where the protective coating is the white material. You could see where it is no longer. So this may be, I don't know the particulars of um, this location, but it looks to me like there is perhaps a leak from above. The coating material has disintegrated and worn away. You see that the column is rusted. You could see on the concrete surround below, you could see where the rust staining has run down. The moisture is actually oxidizing and carrying away that steel material with it and beginning to corrode these components. Masonry is still a very popular facade material and building material. There are different ways of constructing masonry materials. One type of construction is where the masonry is actually adhered to the like a masonry interior backing. So you're looking at the brick, but the structure of the building is actually a masonry, like a concrete block structure inside, and the brick may be adhered directly to that. That's called a rain screen. There are types of construction where the masonry is still not the structural component. However, it is attached to the structural component on the inside, and there's a little airspace behind the brick um, that functions as in older buildings. It used to function as an insulation. In older buildings, that that air pocket is actually has an insulating quality to it. In modern building, we have different ways of insulating the building with different materials now. However, that air gap between the brick and what's behind it also allows moisture to drain out. And depending whether you have a rain screen or whether you have an air pocket, an air space behind that brick determines what types of moisture controls you need to construct. And we'll dip into that a little later in the presentation, and what to look for in terms of aging and maintenance for those items. So as masonry ages, especially in older buildings, you will see just by natural settlement of the building, and also in older buildings that are wood constructed, that have a wood frame inside. They may have a wood or timber frame inside, and the exterior of the building is masonry. The interior wood frame structure over decades and decades will actually shrink. The wood, it's a natural material. It shrinks and it warps over time. And it can change just very slight, so ever so slightly, the shape of a building. Sometimes you'll see a sag in the upper floors of the building. This doesn't mean there's anything necessarily structurally wrong with that older building, but it may be the result of shrinkage of that older wood framing. So when masonry is on the outside of those older wood framed buildings, you will often see this is an example of step cracking. So you'll see, and it looks like a set of stairs that goes up, and you will see it mainly through the mortar joints of the brick, but it also may pass actually through, break one of those brick components in half, and continue up in that stair fashion through that broken brick piece. I want to point out that if you see this in a newer building, this is clearly an older brick, and you could see that step cracking happening for the reason I just explained. Sometimes on newer brick, and I'm just going to go back a slide here. Sometimes on the newer brick structures, you may see a diagonal or step crack emanating from perhaps the top corner or bottom corner of a window. You may see some vertical cracking in the brick in various locations. That is indicative of a different type of deficiency. I won't get into that here, but I just want to differentiate between cracking in older buildings that have been standing for many, many years and cracking in newer construction. Like, they can be from very different causes. But as I mentioned earlier, we condition the spaces in our buildings. We have many, many modern comforts now. We don't have to rely on open flames in our homes, or opening the windows and hoping for a nice stiff breeze in the summer, we are able to very accurately control the air conditions in our home through HVA systems. So as you can see here from the slide, HVACs, heating, ventilating, and air conditioning. So modern HVAC systems can heat and cool spaces. There are different types of HVAC systems, which I won't get into here, but just very briefly, um, in a home or in many of your clubhouses, you have what's called a split system, in which you may have an air handler, as is shown here, in the attic or in a utility closet. And there's a heating element in there that allows the air to be heated and circulated throughout the building through the duct and vent system to heat the inside of the building. But it's called a split system because there's a second component to that system that sits outside the building, where it's a condenser. That you can often see the boxes with the big fan on top. That's about waist height, that sits outside your home or your clubhouse. And that condenses the air, and through a thermal process will create cooled air that can, through the same duct and vent system, circulate into the house and cool the air. So your HVAC system, modern systems are very dependent on the performance of modern materials. The houses have to be uh, uh, relatively more airtight than they used to be, and there has to be no heat sinks in the exterior of the facade. We'll look at that in a little bit as well, and what to look for. So again, this is a presentation that is geared more toward people who are not engineers. So engineers are trained to look for evidence of things that are going on that may not necessarily be visually observable. I want to give the caveat that we do not have a crystal ball, so we can't look at something and know exactly what's going on inside of a building. But we know just through experience that if there are certain things happening in an exterior of the building, chances are that there's something not good going on inside the building, that there's moisture getting in, and we have ways of investigating that. Some are invasive, some are not invasive, that we have at our disposal. So as a non-engineer, you can only see what you can see. You're going to go through, I'm going to just show you what to look for visually to see how aging or moisture or other types of impacts can affect the common elements. One of the things I want to point out is the last point here. So if you are in a multifamily community, you will obviously have elements, especially in a condominium or communities that have multi-unit buildings where the association is responsible for the building envelope and the building structure. So you have your common elements which you have control over that you can fix, but homeowners are responsible for what is in their homes. Oftentimes the plumbing or the performance of their fixtures, such as the bathtub drain or the toilet seal or something like that. And if those are not being maintained properly, they can leak and they can cause damage to the common elements. So the inside, as I mentioned, the inside of the building has the structural components that hold up the building. You don't see those from the outside. What you see on the outside are the finishes, the things that make the building visually appealing, but they also serve a function as well. And they need to be maintained just like everything else, to make sure that you're not going to get moisture intrusion, which is the biggest cause of any kind of deterioration within a building. So obviously you have the roof. There are many types of roof. Most residential buildings have the shingle roof, the sloped shingle roof. Some condominium buildings have a flat roof. They have a different sort of drainage structure on them. Essential to maintaining the health of the roof is the roof drainage, and obviously in this particular case consists of the gutter and downspout system. Gutter and downspout systems need to be maintained regularly. They need to be cleaned. Anything that is damaged on them obviously needs to be repaired, but not just for the sake of making repairs and having it look nice. The gutters and downspouts form an essential function, and they also protect the building at the foundation level. So a lot of water comes off the roofs. Roofs are impervious. It's not like where it rains on the ground and some of the water gets absorbed. Whatever comes off the roof, it's all coming off the roof and it's going into your gutter and downspout systems. If they are leaking, if they are, if your roof systems are not leading the roof drainage away from the foundation of the building, you can start having problems at the foundation with water seepage. It's very important to maintain. So there are obviously different types of facade materials, as you see here. The windows also can affect the performance of the building envelope. Very important also, you see where it says intersection materials. The facades of many buildings have um, a different material on the lower portion or first level or first several levels of the facade and something different above. Where those dissimilar materials meet, it's very important to have proper moisture controls there and make sure that the components there are in good shape. So you can keep the moisture out of that lower facade, and we'll look at that in a little bit. Flashing. You always hear people complain about the 50-cent dishwasher part that ruined their $800 dishwasher. So flashing, it can be kind of like that. Flashing is it is a very often a very small piece of metal or water impervious material that is put at different points of the buildings where materials are different or where there's a change in grade in a building. The flashing needs to be installed and it needs to be lapped properly during construction to make sure that moisture doesn't get in there. So we have two examples here. We have a good example here, and this looks like it's a sidewall flashing. So this is where, say, a facade of a building comes down and intersects with a roof, whether it's this looks like a flat roof here. So if you were to be standing on the roof, like a lot of buildings have, say, a bulkhead that comes up where you could take an elevator up or you could walk up the stairs and walk out of the building. If you walked around the side of that bulkhead, you could see where the flat roof meets the wall of that bulkhead that comes out. This would be a similar location. So you can see that there are several layers here. The flashing, that is that little, there's two little pieces to it here, but the main takeaway here is that you could see that each of these materials is lapped. The top material is lapped over the bottom material. You don't see the opposite. In the bad example here on the right, you could see that the counter flashing, that little kind of zigzag flashing there, is lapped over top of the house wrap. So any moisture that gets behind the facade, rolls down the exterior, is not going to be shed off by that counter flashing. It's going to go behind the counter flashing. It's going to miss the sidewall and flashing in the underlayment entirely. It's going to get underneath that roof sheathing and get to those components that are on that flat roof. So it's very important with flashing that it extends the proper distance behind the other underlayment materials, and that everything is lapped from the top, everything over from the bottom being the bottommost layer up toward the top, with the upper layers being the topmost layers. So the last point is very good. Just think about gravity and rain. Rain rolls down. You don't want it to roll behind something. You want to roll over top onto the next layer that is there. So here's an example here. So if you are many times we will get a request to come out and take a look. There's water coming in. Where is it coming from? If we see something like this inside of a building where we see that we remove the drywall, maybe the gyp board on the ceiling or wall has already deteriorated to the point where it's come off. Sometimes if we remove it, if we're doing invasive and there is water staining, say on a ceiling, and we remove that, we might see staining as we do here on the joists and the subfloor material. And it looks like here in this particular picture, there were perhaps drips coming down the wall. So that water is migrating from somewhere else. So ruling out the neighbor above you having a toilet leak or a faulty bathtub or plumbing issue, this water is most likely coming from outside. So if the area of the leak, leaks can migrate to the interior of the building from outside. I have seen uh, outside um, facades that were deficient. They were letting water in, and that water was migrating a room or two into the interior of the home. And it looks like there's an interior leak, but it's not. It's water that's migrating from the outside. So water on the way in will do a lot of damage. So when we're doing invasive testing, as I mentioned earlier, we'll start oftentimes if we suspect a problem, we'll start with some moisture testing, which is you are poking holes sort of through the mortar or through the materials that are there to get down to the sheathing to take a moisture reading. And depending on that moisture reading gives us an idea of the level of moisture that's entering behind the facade. So in cases where there is above a certain percentage moisture reading, we know that the wood is at least wet. It's getting wet on a regular basis. Above 30% moisture, we know that there's actually free water sitting in there. If we open the building, then we're gonna see water. If we touch it, where our hand is going to get wet. And it can happen. I have seen it. So in this particular case, there was likely an invasive um, investigation done. This looks like perhaps a portion, a structural portion of the building that projects farther out from the facade. It looks like there was water that was perhaps getting in there. Invasive inspection was done. You could see that this sheathing is rotted. The sheathing is rotted away at the exterior. You could see the framing members on the inside of this. Now, when we do an invasive inspection, we're opening up one portion, but in order to find out where that water is coming from, we often have to expand that investigation and keep taking off, unfortunately, portions of the outside of the building to figure out where that water is entering. Sometimes it's easy, sometimes it's not so easy. Here's a case where the windows were likely not flashed properly. Now, windows can, the window unit itself sometimes will have a self-flashing mechanism in it where water is weeped to the outside of the building. However, whenever you are making a window or a door opening or any kind of opening in the facade, you need to flash it properly so that water that's rolling down the outside of that facade, again, that flashing is lapped properly to shed that water. If penetrations through the facade are not flashed properly or not protected, that water can again get in there and get to those structural components. So here we have a sort of a turret bay window. The windows were not flashed properly. You can see the moisture damage. This facade is removed. You can see the building paper here exposed, and you can see the beginnings of water damage to the inside of that structure. The roof is one of those portions of the building envelope. I touched briefly on roof drainage, which is very important. Roof itself needs to be flashed properly, and again, that flashing needs to be lapped properly. It's not just good enough to install the flashing; it has to be installed properly to ensure you're not getting any moisture, protect against that moisture getting in there. Obviously, as components age, there's a point at which they can no longer be maintained and they need to be replaced. But to realize the full useful life of those components, you want to make sure that things are constructed properly, flashed properly, and maintained properly so you can realize that full useful life. So here's some different components of the roof. We oftentimes will have the vent that comes up. You've got if you've got a bathroom in there, you've got a vent. Any time wastewater has to drain out of a building, there's a vent that needs to come up through the roof or through the facade at some point. Um, Roofs are constructed with a sheathing material, oftentimes wood, and it's overlaid by an underlayment that lays underneath the shingles or whatever finishes on the roof membrane. There are flashings, just like on a building facade. There's flashings wherever there's an intersection or a penetration through that flashing. So that would happen, as you see here, dormer windows, chimneys, skylights, anything that comes up through the roof. Oftentimes on a flat roof, there are conduits that come up for the cooling units that sit on that roof. They all need to be protected somehow. And then on roofs, there's drip edge at the edge, at the eaves and at the rakes to shed that water, make sure it is coming off of the roof. It's not migrating under the shingles at the edge. So just here's some real life pictures. You see a roof vent coming up here through the roof in the picture on the left. Notice how the shingles lap the flange on the boot. There's the white pipe you see is the actual vent that comes up through the roof. That little kind of black collar that sits around the base of that pipe next to the roof with that little kind of flat horizontal piece, that's called the boot. So you have the vent comes up, the boot sits over top of that vent, and that boot allows the shingles to be lapped properly with that penetration and protect that opening from water. So you see how the shingles are lapped over top of the flange on the boot from the top. On the left-hand side, I am assuming that this is being taken apart because there was water coming into the skylight here. It was likely not lapped properly from the shingles, and water got into the penetration where the frame for that roof, or where that skylight comes through the roof. Kick out flashing. Kick out flashing, this is one of those little piece of metal that does a big job. So in this particular picture, you see a vertical wall of the facade, and there's a roof that comes down and butts up against um, that facade. Now, the building code specifically calls for kick out flashing in these locations, which is, you can see the orange arrow pointing at kind of that little bent piece of metal. So that the roof and the building facade, and you can kind of see it peeking out a little bit there underneath the vinyl siding, has flashing in there as well. It's protecting the sheathing on the exterior of the building and the roof sheathing with those pieces of metal there. Those pieces of metal are lapped actually with the shingles. It's not one continuous piece in that roof valley. It's lapped with the shingles so that as the water rolls down, it continues down the roof, does not get under the shingles. Eventually comes down, hits that kick out flashing. Purpose of the kick out flashing is to keep the water from continuing to roll down the facade. So it is doing what its name says, it's kicking the water out and away from the building. Very important piece of flashing in this particular location. Here's an example of where kick-out flashing is not installed. You'll see again in the left, there's that vertical building facade with the roof coming down alongside it. There's no kick-out flashing there. And it's compounded by the fact that there is a material transition there. Notice that on the bottom of that first level of that building, there is a masonry facade that projects out a little farther. Then it looks like you've got a board and batten type material. It might be AZEK, it might be vinyl, but it's above that facade, and there is where that roof comes down. It's actually just allowing water to dump on top of that material transition there. It's kind of a ledge that is in this particular case, it's probably protected by some flashing itself underneath there. But where the water comes down and hits that ledge, there's something going on there where the flashing is not protecting the internal components of the building. Now on the right-hand side is a thermal image, and we can do that with a thermal camera from ground level. And what the camera is capturing is differences in temperature between the inside of the building, the inside of the facade, and I should say where it's not capturing the inside of the facade, but it's capturing how the inside of the building is performing and affecting the amount of heat that's coming through the outside of the building. So in this particular case, it's showing that that valley is much, much cooler. And that indicates this is one of the tools that engineers have at their disposal to see if there is perhaps a problem going on behind the facade. So in this particular case, you could see that this is cooler, and we can see that there's no kick out flashing. This is probably an area of interest because of the way it's configured, and you can see that there's a little bit of a problem there. So what we would do, I just want to go back, we would probably do a little moisture testing to see what's going on in there. If there's an indication of a problem, we may recommend some invasive testing to see what if there is actual damage, depending upon the results of the moisture testing. The roof again, and I'm going to move a little more quickly here, just so that we don't run out of time. So again, same thing. You want to protect it at the chimney just like you would at a vertical facade. You want to make sure everything is lapped correctly. You want to make sure things are caulked. You'll see that this is being caulked here. That caulk needs to be maintained as part of regular maintenance to protect against water getting into this assembly. Gutters and downspouts, I touched on them earlier, so I won't touch on them again here. Maintenance, very, very important, making sure that if you have a subsurface system, that it's functioning properly, that it's connected to the downspouts properly. You want to make sure this is maintained. Windows, I touched on them earlier. If you see any indications of mold or deterioration of the facade, I mentioned brick earlier. If you see cracking in the brick emanating from the corners of the windows or the sills, it may be an indication that there's moisture getting in there. Things may not be flashed properly. Or perhaps the weep system, if you have an integral weep system on the windows, maybe it's clogged, maybe it's not working. You want to investigate that. I will go to brick weeps. So we talked earlier about rain screens and about air pockets behind the brick facade. You will oftentimes see if you have an airspace behind that brick facade, there will be weep holes, or in this case, this is a mortar space that is open to allow that water, any excess moisture behind there, to come out. Even in the case of a rain screen, there'll be a drainage plane behind there. Any kind of moisture that might accumulate behind there, you want to make sure that at the base of the brick, wherever the brick terminates above something, whether it's the foundation, a window, a door, a roof, you want to make sure that there's flashing there. You want to make sure that there's some sort of moisture control there to make sure that the moisture that's accumulated behind that facade can exit. Any sort of penetration, as I mentioned before, that includes any kind of conduits or anything. You want to make sure those are sealed. So there's a way to flash penetrations at the interior. If you have any kind of masonry exterior, you want to see those penetrations sealed with a material that can expand and contract. A lot of times I see these areas just grouted shut with a grout. That grout will eventually deteriorate. So it's best to seal those areas with something, an elastomeric type of material that can expand and contract, so that whether it's hot out, whether it's cold out, that area is protected. Intersection of materials, of dissimilar materials I talked about. In this case, we have what looks like on the left to be an AZEK exterior facade. It meets the brick facade. You want to make sure that area is caulked. This is areas, because materials expand and contract differently, they'll have different movements under different temperatures, and an opening, a crack can form there. You want to make sure that these materials are properly caulked. On the right, we see between an aluminum window frame and a masonry exterior, this needs to be caulked. It needs to be maintained as part of regular maintenance to ensure that it performs over time. Decks, real quick, there's a couple components that you want to take a look at. You want to make sure that the ledger beams are in good condition. This is what supports The deck on the facade side, you want to make sure that that all the fasteners are there. They're not rusted. They're not missing. You want to look at the footings. Oftentimes, the footings are exposed, the concrete footing. You want to make sure that that is in good condition. The handrail posts, you want to make sure that the railings are not loose, that they're properly not properly fashioned. That would be more in the engineer's realm, but that those fasteners that you see are not missing. They're not deteriorated. If you see any of that, you want to have that evaluated. I won't get too much into decks here just for the sake of time. I'm more than happy to discuss that with you offline. Again, wherever a deck component penetrates the facade, it needs to be flashed properly. There is a proper flashing method, usually that is specified by the manufacturer of either a manufactured sheathing material or the house wrap material that talks about how things need to be flashed when there's a structural penetration through the facade. So let's talk about costs and preventive maintenance. So obviously things wear out. Everything has um, a useful life. Things need to be replaced over time. So there is a cost I touched on earlier. There's a cost to living in your house. There's a cost to maintaining the building that your business is in. And there are long-term costs. There are life cycle costs. It's the cost to continually replace those items and maintain those items as the building ages. So what do engineers turn to for useful lives? We have a couple different resources. This particular publication is mentioned in our bibliography of different types of reports that we do, specifically reserve study reports. So there is information that is published that you can refer to if needed on useful lives and life cycle costs for different components. Oftentimes, engineers also by experience will know what the useful life of a particular material is. Um, okay, so HVA systems, again, HVA systems are integral to the air conditioning and the health of our buildings, making sure pipes don't freeze, in some cases, controlling moisture levels within the building, can extend the life of certain components. Older HVA systems are relatively inefficient depending on how old it is. The newer systems can be more efficient. Again, the performance of your HVAC system is also dependent on the health and performance of the materials of your building envelope. If you are leaking heat from the windows, you could have the best HVAC system in the world. But if you are leaking heat, that the effectiveness of that system is obviously is not as effective. So when we're looking at, let's say we have a building and we have an older HVAC system, it's time to replace that system. Going with a more efficient system and making upgrades to the building to work in conjunction with that system may have a more expensive upfront cost. But over time, the life cycle cost of doing those upgrades and using that more efficient HVAC system will will even out over time. You will eventually reach a break-even point where even though the upgrade has a larger upfront cost, over time, the cost of maintaining that system and those components and the cost of your energy costs, even though they're not something tangible in the building, they are part of the cost of running a building. So when you look at those life cycle costs over time, you will see that because that system is more efficient, it's saving you money over time. There's a point at which your return on investment for installing that more efficient system, it reaches a break-even point and starts to exceed the performance of the former system. So it ends up being a cost savings over the life cycle of the component. So there are different kinds of programs depending on what state you're in, New Jersey, Pennsylvania, New York, Delaware, that can assist with the costs of those upgrades. You need to take a look. Here is a website that has the different incentives by state, which you may qualify for to help with the cost of those energy upgrades. So slowing down the aging process, the only way to do that is maintenance. So there is, again, I'm going to move a little more quickly through this section. Here's the slide I want. So there are different types of maintenance. You want to do preventive maintenance. You want to keep the maintenance in that realm. Preventive maintenance is sort of, think about your as you maintain your health. You have preventive health measures. There's things you do, eating healthy food, getting exercise. These are preventive measures against any kind of disease or deterioration in your body. The same thing with preventive maintenance for a building. You are trying to avoid the things that will cause damage in your building. As we move on to the next level is corrective maintenance. So the damage has already happened. Sometimes you can do all kinds of maintenance and things still age. The physical world still tends uh, toward chaos, and things deteriorate in the physical world. So at some point you will need to replace that item, or you may need to repair a component. So at this point, the deterioration has taken place. I want to stress that corrective maintenance, and that the end of that sentence is very important. You want to correct with the goal of remediating the problem. So when you do corrective maintenance, half measures may be maybe less expensive, but you want to find out what the source of the problem is. You want to correct the source of the problem and make a proper repair. Otherwise, the repair down the road will be much more expensive. And obviously, deferred maintenance is a postponed maintenance. Postponed maintenance will translate into greater repair costs at a future date. So just in the spirit of preventive versus corrective maintenance, there's a point at which you can look at a component and you can see we need to maintain this, whether it's the caulk I mentioned around the windows. This case is not a building, it's a roadway, but we can see that the roadway is starting to deteriorate. We want to maintain. Actually, the picture, this picture of this road is into corrective maintenance territory, but you understand the idea. As your pavement ages, you want to seal cracks. You want to make sure that you are doing that preventive maintenance so that you don't get to the functional failure down the road. As you can see here, these materials are no longer performing. You can no longer maintain them in any reasonable and cost-effective fashion that's going to do any sort of good. So you want to keep things in the preventive maintenance category, and try to extend or even reach that estimated full useful life of that component. So again, I touched on this. One of the important takeaways here of this slide is that in your reserve study, you have a total cost to replace your components. Preventive maintenance over time, it tends to be about 2 to 6% of that annual operating budget, just historically, just from collected data. So that 2 to 6%, spending that on preventive maintenance can avoid much more expensive costs down the road. Again, through collected data, it was found that the cost to perform corrective maintenance on something that's deteriorated because it hasn't been maintained is 30 times the cost of that initial preventive maintenance. So that just highlights the importance of preventive maintenance on your buildings. Obviously, not maintaining your building will make it age faster, but there's also other considerations. So if you live along the coast, again, I mentioned salt water, high winds, extremes of temperature. Oftentimes you will see on the south side of a building where the roof gets baked off much more quickly than the north side because of that temperature fluctuations. And again, exposure to the elements, cold, snow loads, high winds, wind-driven rain, things of that nature will make those components age faster. Again, we touched on the building envelope. It's those components that you can see physically. You want to make sure they're maintained, they're not deteriorating in any way, because you want those to protect the inside of the building, that the components that are holding up the building. Again, just for the interest of time, I'm just gonna just go right through to the reserve study portion of this. Okay, reserves. So reserves, obviously very important. You want to reserve study. I just want to go to, here we go. So there are different types of studies, and actually this one on the far right here, preliminary, should go in front. A preliminary reserve study is done by, if you live in a multifamily community, is done by the developer prior to anything being built. They take the design plans, they do a takeoff from those design plans for the common elements, put together a reserve study for a community that is not constructed yet. It is based on the design plans, and it's based on estimated full useful lives of all the components. They haven't been built, they're not aging yet. So when that transition happens from the developer to the community wants to do a full reserve study based on the constructed community. That's the one on the far left there. So that includes somebody going out to the field, somebody doing a financial or a condition analysis assessment of all the common elements, and a financial assessment, estimating remaining useful lives, and estimating the cost to replace those, and coming up with the different funding scenarios, whether it be baseline, full funding, or type of threshold funding. Beyond that, you will need to update the reserve study as the community ages. That can be done in several ways. You want to have a update with a site visit done at least every 3 to 5 years, just to capture those components that are aging. You want to make sure that you're properly funding for the replacement. In the interim, if you do a remediation project and you just want to do what's called a paper update, or an update without a site visit, to see how that project has impacted your reserves, we can do a paper update to see how that budget is impacted without doing a site visit. But when you're updating a reserve study, you should always do an update with a site visit, so that the condition of those components can be assessed. Okay, I'm going to stop here. And again, I apologize for the for the pace, and that I didn't get to cover some things, but I did want to get a chance. We can give you a copy of this presentation that you can look at for yourself. Happy to chat with you offline if you have any concerns. But I wanted to take these last few minutes to see if anyone had any particular questions. I see one question here. What are the metal lintels below a brick facade, and are they structural? Very good question. Um, Again, the brick facade in a modern building, a brick facade is not part of what's holding up the building, but that exterior facade is integral to the building, and those metal lintels that you see that span the opening, like above a window or above a door, they are very important to the structure of the brick facade itself, to that masonry structure. So yes, if you see metal lintels that are deteriorated in any way, they're starting to expand, flake, anything like that, you want to have that get that looked at. Okay, I have a question here. Are you saying our preventive maintenance budget should be 2 to 6% of the 30-year expenditures from our reserve study? I'm not saying it should be necessarily. When a reserve study is done, we look at the needs for preventive maintenance, and it's going to be specific to your community. However, just across the board, based on the data available, that preventive maintenance budget typically is 2 to 6% of those 30-year expenditures. I hope that helps. If you have a specific community that you live in, you want to look at that as part of your reserve study to make sure you're funding properly. So who should we email for CEU confirmation? There, Chelsea just put in the chat her email. You can email her for that confirmation, and she would also be happy to provide you with a copy of our presentation today.